Okay, hello everyone. My name is Stefano Mazzini, and I'm working for a company. It's called Balsamic. You may have heard of. We do mockups. A product that's called mockups. And tonight I'm going to talk to you about what I've been working on in the past year and a half, I think. So it's about three applications. One is the buy page. So basically, when you go on balsamic.com/buy and you want to buy our product, this is the page you land on, and it's a page where you can basically choose the kind of license you want to buy for our product, and you can choose among several options. It's for buying a license, and then you will eventually have to fill up a form with your personal details and credit card details and so on. The second product I've been working on is we have a version that's integrated with Google Drive, and so but that works on a subscription. Under a subscription model, and so that's the page you get when you want to manage your subscription and see if you want to change your billing information, or you see a billing history, or if you want to cancel or subscribe to a new one. So this sort of things. Again, it's a different application, but it's similar because it shares, for example, if you want to sign up for a new subscription, it shares the same billing information form that you have to fill up with your personal details, for example. And the next one is My Balsamic, which is the hosted version of our application. And it's again totally different application, but in this page you see the plans you can upgrade, downgrade, but you also see the subscription, the subscription status information again, and that's also similar. So basically, three different applications that all share this common goal of talking to Olio, which is our backend. Product that we built for ourselves for managing purchases and subscriptions and in general, our customer base. Just to let you know about the project size, we're talking about 15,000 lines of code, roughly, of JavaScript code. That's almost half split between the UI and logic. And then we have like a nice fourth that's really shared code. And then the buy page is the biggest product because you have several options to choose from, whereas Google Drive is much smaller because there's not many things to click. It's just one product, and so it's very vertical. And My Balsamic is about to grow because we're currently in the focus of porting more code to React. So let me tell you a little bit about my journey in React land. And I started in 2014, early 2014, when React was still in its infancy with 0.5. And at that time, I didn't know much about how to write front-end code, right? And so, because I didn't know anything about it, I gave a talk, my first talk about React, which was actually quite fun because it was a live editing, live coding example. So it was pretty well received. And then in June, I had our first application in production, which was the buy page. Of course, we had a previous version of the buy page already, but since it was a small kind of application, we decided to start from scratch with React and start greenfield so that we could experiment better and get to learn more things easily. But then when I started to tackle the other applications, I started to have the problem about how to work with legacy. So I had some jQuery application that I didn't want to throw away and rebuild from scratch. So I gave another talk about how to refactor a jQuery application to React. So that was starting to get interesting, and by the time we had our second application in production, which was My Balsamic, I was starting to fight and wrestle a little bit with the state of different applications that share a common part of the code, and they have to somehow maintain certain things the same way. And that's what I call the fighting with state period, right? And so Flux came out in 2015, and so I gave a talk about how to organize the structure of your application using Flux. But Flux, as you know, there's so many different frameworks, Flux frameworks out there, that it's a really good idea, but it doesn't tell you exactly what to do. So I wrote my own, and by the time I had my third application in production, which was Google Drive, I was really having three different attempts in place to how to tackle state management, right? And so I wasn't really happy with the way it was coming out. Luckily, in July there was the React conference in Paris, which was really mind-blowing. I learned a lot of stuff, and one of the things that I really liked was Redux, and so I fell so much in love with it that when I came back, I took the entire code base and refactored it to Redux, and now we have it in production for the whole three applications. And so tonight I'm going to tell you about what I learned in the process. And I don't know what this phase is, but I feel that I'm trying to keep the complexity at a manageable level. That's what I'm trying to do basically now. So I'm going to tell you about my past attempts. So what I how I try to manage state in my first attempts, and then the concepts that I came to crystallize in my head about how to manage state and functional programming as opposed to object-oriented programming, this sort of things. And of course, this is in the concept of Redux, which I think is a really good paradigm for both having efficiency and code readability in your code. So it's really nice. So my first attempt. That's what I call one store to rule them all, but I didn't really like it, so in the end it was like ruining everything, but this is what it looked like. So how many of you are familiar with the Flux architecture? All right, good. So this is, according to Flux architecture, you have actions that come into your system that mean something like do something, and so you have the store that is the holder of the information that updates itself, right? And then when it does, it fires an event, and there are components that listen to these events so that they can re-render, right? Because they know that something has changed in the store. But if the action changes something that's slightly different in the store, so a different portion of the state, then you have a different event. I had a different event that was fired, triggering the re-rendering of different components, right? So all nice, all good. But then, and so, for example, this was sample code. I had this, this may look familiar to you or not, depending on whether you use one of the Flux frameworks out there. But when I started, there was nothing out there, so I wrote my own, as most people did back in the days. And so my events are just little things like store that selected product change event that I could just fire. And then I had this force update mixin ready-made to inject into my components so that they can re-render when the event was fired. And so I had this, for example, this component that was re-rendering whenever the user selected a different product, right? Or I had this other one that maybe re-render when the user typed something in the billing information form. So some user info changed, and so. By the way, can you guys read from the back there? It's a little small, but couldn't enlarge it more. Or maybe I had a different one that shopping cart changed. So you get the picture. Different events, different components. But then at some point you get one component that rightfully needs to access different kinds of information in the store, and so wants to listen to all of these different events, and it starts to get hairy after a while. So I decided in the end to just have one single store changed event, right? It was simple. Everything that happened in the store was just triggering this event. And it looked like this. Basically, the action was coming in, the store updated itself, and then fired this event. And then, boom, all of the components will render themselves. So, and this is not optimal. This is not optimal because, of course, we have virtual DOM, so it's fast and efficient and everything, but still, you don't want every component to re-render, right? And besides, my store was becoming a monster. It was collecting so much stuff that it was not nice to look at. So I decided to take another approach with the second attempt, the one of having many stores. And I've seen many people, doing this. And so basically, you have an action that goes into store A, which updates itself and fires an event, and you have components listening to that. But the action maybe hits on a different store, and a different action hits on a different store, and so the second store updates itself, fires a different event, and different components update. And this approach solved many issues with the monster class because I was able to split it up into more manageable components, And so, the methods got distributed a little bit, and so it was not a monster anymore. But it wasn't really solving my problem of having these components listening to several different kinds of events, because if you remember my previous slide, it was like this, so there's not much difference, right? And so you still have, some events that are fired by store A that many components want to listen to, not only, the top ones. And the store B also fires an event that many components want to listen to. So basically, you have spaghetti in the end, anyway. So again, was not really solving the problem for me. And the ultimate reason for that was that I was putting the cart in front of the horse, basically. What do I mean by that? When you decide to have a store that is an object, like I did, according to OOP, an object is, data plus methods, right, that deal with that data. So in a way, it's an upfront decision that you make when you try and decide of how to build your store. So you think about your system in a high-level perspective, and you say, well, I have, user information because I have a billing information form to fill up. So that's obviously store. Then I have, maybe product selection or the shopping cart. That's obviously another store. And so you start to make these upfront decisions. And once you have, decided that you have a class with a given responsibility, then the methods have to go inside that class for changing the state that the class is responsible for, right? But the thing is that you don't know what data you need and where until you've written your UI components. So it's only when you write your UI components that you really know what data you need and when and where, right? So that's why I say that building a store as a class is sort of an upfront decision, because you still set it in stone. Like a class is a little bit, you can refactor it, of course, but still you have to do it. So here comes Redux, and to me it was a lifesaver. So Redux works this way. Basically, you have still actions that go into one store. So we're going back to my initial attempt of having one store. So that's the way Redux works. You have one store which fires one event, one kind of event, and that event goes to all the components. So, but it's not the same as my attempt. The difference is that in the Redux we have two different kinds of components that are smart components and dumb components. It's a terminology you might like or not, but a dumb component is just a regular component, a React component. A smart component is a component that has in front a little selector function. So basically that selector function just needs to take the whole state of the single store, the whole thing, and cut those few pieces that the component needs in order to render, and select a little subset of the whole state and provide that to the component. So each one of those will become a property for the component. But that I think is that that little result can be tested to see which components need to re-render, because only those that see those partial view of the state change from the previous rendering cycle do re-render. And so this is now optimal, because only the components that need to re-render will actually re-render. So this is a very good idea. And a little bit of terminology. So we have the store now is not an object anymore. Not an object anymore. It's just a set of plain old JavaScript objects. It's just a dictionaries and lists, basic data types. It's not an object anymore. And then when an action comes, it is functions that are called reducers that take the whole state and recompute a whole new state with the effect of the action. So it may seem inefficient because each one of these reducers will take the whole thing and produce a whole new version of the whole thing. But it's not inefficient, as I will show you later. And then the selector functions are made available through the connect utility function. If you look at the Redux documentation, you can see that this is not necessary, but that's the way I like to write my code, so I will use connect. And by the way, I strongly recommend you to go and read the Redux documentation because it's really well written. It's a little long, but it's a very nice read. So check it out. So here's a little different visualization of what happens. So basically, you have the store, which, as I said, is the whole state holds the whole state of the application. Then the selector functions, handpick a few bits here and there, which become properties to the components, and then the components render. Then maybe one of these components will have a button somewhere, so there will be an on-click event alert that will fire an action creator. And the action creator, sure enough, creates actions. So the actions come into the store, and the store, using the reducers, will compute a new version of the state, the whole state. And then again, this, this may not be the only place where you have actions being generated. You may have, for example, server-side notifications, or maybe you have a timer going on in the background that generates other kinds of actions. So it doesn't really matter. As long as you have an action that comes in, a new store state is computed. And so with the new store state, the selector functions are executed again. And if they generate different properties for a given component, then the component, of course, is re-rendered. If they don't generate different set of properties, but they're the same as the previous cycle, then the component doesn't re-render. And so this is really nice. So let's take a look at what the code looks like. So this is an ES6 component. So this is using the ECMAScript 6 syntax for defining a React component. And it's I cut a few pieces of code here and there, so it doesn't really make much sense, but hopefully you'll get the picture. So I'm assuming we have a saving property in the component that I use for showing up a spinner. So if I'm saving, I'm showing up a spinner. Otherwise, I'm assuming I have some validation errors that I can use to show maybe a form with the errors. And then I have probably a button somewhere that I can click, and that's the way you dispatch an action. So basically, that dispatch method is available from the, it's got to be available somehow, but it comes from the store, and the Redux store only has two methods. One is dispatch, and the other one is getState. So it's really simple, very simple API. And so you dispatch whatever comes out of that action creator save changes. And I like to write my action creators inside, I like to collect them all inside a module that I call Redux actions, or maybe I split it up into several modules, but I like to export them in this way. And then when you call an action creator, you can, you can send in as parameters whatever you have inside the internal state of the component. So this is just a regular dump component. That's how they call them. But if you want to connect it to the Redux framework, then you use the connect decorator that I showed you before. And this is ES7 syntax. Of course, you can also use ES6 or ES5 syntax. It comes a little bit more prolix or maybe less readable, but it's the same thing. So you can choose your own way. And so, as I said, you specify a function that takes the state, the whole state, and simply computes a dictionary of keys that will eventually become properties, right? So you can see here the saving property, and I dig the saving boolean out from the state inside this plan switch object that I have obviously inside the state. But look at validation. Like validation, this is a function, so I can I can compute the validation errors right there. And that's actually a very nice way to do validation, because sometimes maybe you have a very complex sign-up process where you have several screens, and in screen 5 maybe you want to give errors based on what the user inputted in screen 1. So it's not always very easy to keep track of the state, but since you have one single place where you have all the state of your application, that's really convenient actually to write a function that computes it that way. And so you may think now that this becomes inefficient, because as I said, the render method is not always called, but it's only called when it's necessary, and that's good. But the selector function is always called. No matter what happens to the state, if an action is being triggered, then all of the selector functions in your Smart components get re-rendered, so get re-executed. So you may think that this becomes inefficient, but that's when you want to do memoization. Oh man, that doesn't read much. So memoization is a standard technique from the functional programming paradigms, where you take a function and you replace it with a decorated version of the same function, where if the parameters didn't change, then the output is returned from the previous run instead of re-executing the function. It's basically a way of caching, and it's really effective in this situation. So again, it's not inefficient in the end. So you can make it very efficient. So let's compare this approach with my previous components, my previous attempt when I had a store that was an object. So as I said, I had like one event, and all the components will re-render. And as I said, like if you look at the difference in these two slides, you will see that down there, I get the validation errors from the store. So when my components will re-render, they would reach out to the store and call the appropriate methods to get the information that they need, right? So it's not much different than here. In fact, the implementation of this method that I had here is the same as this function here. But the difference is that before, I was forced to have that implementation in the store class. And so it was becoming a monster because I had many. But now I'm free to express them as functions that I can disperse in how many modules I want in my code base, right? And I don't need to stick them all in the same object. So this really solved my problem of having a monster class. So let's see how the action creators look like instead, right? So an action creator looks like this. So it's a function, and the whole purpose of the function is to return an action. And this is pretty much what it does. So this is the simplest possible action creator. The actions look like this. So now, luckily, there has been an effort of standardizing the Flux actions. So look it up. It's called Flux standard actions. And the way it works is that basically those actions are supposed to be just plain JavaScript objects with a type and with a payload. And the payload, you can do whatever you want, but you have to have a payload. And then maybe you also have an error, which must be a Boolean. And if it's true, then the payload must be an error object. And this is actually the best part of the contribution of the standard, I think, because it's pretty easy to get error management wrong. Like, for example, I initially did the classical mistake of sending out error strings, error messages, for example, in response to an Ajax query. And that wasn't good because after a while, maybe you have bugs in your code, very likely. And then you realize that just a string is not enough. It's nice to have the whole error object because you can console log error.stack and you get actually stack trace, which is very good. So this is a nice way to do it. So this is what actions look like. This was the action creator, very simple one. But then we can have asynchronous action creators, like this one. Basically, instead of returning the action, you return a function that takes the dispatch method, which is the same as before, that we saw before. So, basically this turns the action creator into a generator. So you can dispatch as many actions you want, and of course you can have your asynchronous calls inside. And I like to wrap my API calls inside a module that abstracts away the dependency of maybe on jQuery that I have, or a super agent, much better. Check it out. So, I like to have these functions that expose a uniform promise-based API. And so this is the way you implement, for example, saving. So you dispatch an action right away to, show a spinner, maybe. And then when the network interaction is completed, both either successfully or with an error, you get another action that updates your store. Now, let's take a look at the real meat of how you update the store. And this is what the reducer looks like. So again, if you look at the Redux documentation, you will find different, slightly different kind of code because there's more boilerplate. But it's good for documentation because then you figure out exactly what's happening. But you're encouraged to write your own, boilerplate reducing code because if you look it up in GitHub, you'll find different ways of try to reduce the boilerplate. But they're all 20-liners. And so you're encouraged to write your own. It's much easier. And so I like to write my reducers in a way that I collect them all in a dictionary. And the key is the action type, and the value is the actual reducer. So this is using the spread operator of ECMAScript 6. And as you can see, it's a function that takes a state and the action and computes a whole new state, right? So you always start with spread state, and then you change whatever needs to be changed. In this case, for example, when I start saving changes, I go and flip this bit to true so that I can show the spinner. If you remember how the component was implemented, you will remember that I was accessing state, plan switch, saving, right? So that's the spinner. And when the interaction with the server is done, then I put it back to false and I save the document or the error depending on which one I have. So it's really simple. Now, how many of you are familiar with the spread operator? All right, so let's take a little test. So now let's assume that you have a dictionary A, and which is made of 3 nested dictionaries. And then I create a dictionary B, which is copied from dictionary A. If I print this, is it going to be true or false? True? False? There you go, it's false. Because it's, it's actually a different dictionary. So you actually create a new object. And the triple equals operator is actually checking just checking the pointers in memory. So it's really fast, but it's only pointers. So if the object must be different. And what about this one instead? Nested dictionary 1, if you don't read. True? False? It's true, because then you actually reuse the same value as before. So this is really efficient. Again, what about this case? If I copy the nested dictionary 2 from there, true? False? This is true, because I do by hand exactly what the spread operator does. So I take exactly the same reference from the previous dictionary and I put it into the second dictionary. So well, and then the fun goes on, but we don't need to. Dictionary 3, of course, is different because I create dictionary 3 from scratch, so it's a whole different object. The point of this little exercise is to make clear that the use of spread operator together with the triple equals is a very powerful combination because it gives you the semantic. So if you take this coding convention of always returning a new object using a spread operator, then the triple equals acquires this incredible semantics of telling you whether two data structures are deeply equal in one go. So you triple equal two objects, and just with a pointer comparison, very fast, it will tell you if they're deep equal. If there's only one bit different, lost inside your structure, it will be false because you always return something that's new. So that's really important, and that's a basic assumption of Redux. It all works based on this assumption. So, what's my take about functional versus object-oriented programming? Because as you saw, the Redux approach that I showed you with the reducers is very much functional. You always compute new states, immutable state. By the way, you can use immutable JS if you want to, but it's not really necessary if you use this trick of the spread operator. So this is what Redux approach looks like, and with my initial attempt of having an object instead, this is what it was looking like. So basically, I had a store, and I was in the constructor was building it, and that's the plan switch object that contains the saving boolean, and then I have a document and an error. That's the how I initialized it, right? Then I had my own way, as I said, I wrote my own Redux thing, right? So I had my own way of intercepting actions, and this was the start saving changes action. And I was just changing the bit and saving to true. And then this is how I was handling the done saving changes. So I was flipping the bit back to false and storing the document and the error. But then, of course, if this was my implementation and I liked hypothetically the approach of Redux of having those selector functions, that wouldn't have worked because if my component needs to figure out whether something has changed, it cannot really use the triple equals because in this case the store instance doesn't change. I mean, the instance is always the same. I change inside, but the object is the same. The plan switch object is always the same. I don't create a new one. I just change that one, right? So it wouldn't really work. I would have had to implement an actual deep comparison algorithm, which is sort of defeating the purpose, right? In fact, this is what all the Flux architectures look like. You have to change a bit and soon after fire an event to let the rest of the system know that you did change something, right? So that's how I was creating events, and I was firing an event after flipping the saving bit to true or false. And then, of course, down here I had a different kind of data that I was changing, so I was also firing the other kind of event. And this is going back to what was my initial point of having too many events. After a while, you start, just to make sure, fire many events, or maybe just have one event because you didn't know why, or your why wasn't updating when you were changing some stuff. So this basically is micromanagement of the state. And this is so typical of object-oriented, of imperative programming style rather than functional style. where you do things and then you have to take care about the order of execution of things, notify the rest of the system that something has happened, as opposed to functional approaches where you just describe what happens to your system in terms of functions, and then it's the runtime that figures out what changed and what needs to happen next, right? So this is I think how this is. Yeah, I'm really happy that Redux is a different approach because it's so much more readable. Now, I wanted to show you a little demo about what you can achieve with this approach. So this is the Google Drive example. It's slightly, it's not. Well, it's a little small. Doesn't matter. You don't have to read. So well, this is just the application where you can choose. You select your plan, and then you fill up your form. You choose your stuff. You fill up your form and do whatever. Now here on the right side you have the Redux Dev Tools. So basically, because every Redux application has to have one store that has the state of the whole application, and there are actions. The runtime doesn't know anything about your application, of course, but it knows one thing, that there's one state and there are actions. And so you can keep track of those, and you can build amazing tools on top of that. For example, this one, you can inspect your state and navigate inside your current state of the application, and you look at all the internals of your state. And these up here are the actual actions that happen, and you can see everything that happens. But you can also interact with it and make it so that it never happened, and you go back in time. So this is a they call it time traveling debugger, because you can go back in time with your state and simulate like it never happened. And this is all because you have the state and the tool is in control of that state if you want to, right? So you can do interesting things. Another very interesting thing you can do is that you can hot reload your code. So if I take the source code of this application and I change it and I save it, I said, then you'll see appearing up there, right there, and you can do background color red, stuff like that, and you save, and then boom, everything happens in real time without you having to reload the page and go navigate to the same state of you're currently working on. For working with the UI, this is really convenient because you just navigate. Maybe it takes like a couple of minutes to get there. Select the right option and everything. Then you see something that's out of shape. Oh, you want to work on that? So you go on the code, you change it, you fix it, you save, and you see it right there. So it's really convenient. And this is all because it's a functional approach. So you have the state that's always there, and your tools can access it in a standardized way. And since I'm done, yes, question.
Only when you're ready.
I am ready. I was going to go to the thank you page.
I
So
mean, with state that that's not necessarily inside your app, but for example, the hash of the location bar.
You mean navigation?
Yeah, because that's also state of your app.
Yeah, exactly. Very good question. So yeah, absolutely. So well, on one hand, I will tell you check React router out. And there's a Redux router also thing.
How does it fit into this idea of?
It fits in the sense that well, first of all, you don't have to. It's not like a black and white kind of approach. You can still have an application that has state. It's all the way, but you also have a part of it handled with Redux, so you can mix and match, even though maybe it's more complicated.
But then this time travel would just not work, right?
Of course not. Yeah, only partially. But it's actually very possible anyway, because if you in your navigation logic you simply have to intercept the time when your whatever library, low-level library, intercepts the hash change or something, and fire an action from there. So from that point on, you model your URL as a state in your Redux.
Yeah, but you want this relationship to be two-way. We want to have a two-way binding between the actual hash and your representation.
Yes, and for that you can do basically another hidden method of the Redux store is listen. So you can listen to store changes, just like the DevTools does. So you can hook into the store and see from the outside whenever it changes. And so you can compare, whenever you see a change, you compare to the previous state and see if the URL changed, then respond to that and update the URL. So I think that's exactly what the Redux router does. I haven't checked it out yet though, but it has to be that way. Yes?
I have a number of questions. First, the simple one. You impressed me with going back in history.
Uh-huh.
Does it mean that
I can do
all
the
actions are constantly stored in memory? Because
yeah. In that, yes, but only if you activate the Redux DevTools.
Okay.
So it's
a feature of the tools.
It's a feature
not
of
the
tool.
framework, which when users use it.
No,
you don't have any going back to history.
No, absolutely. Okay. So in fact, it's a very good point, because if you use the Redux tools, you will feel it. If you work on it for a few interactions, then it will start to be slow because it's collecting everything. But that's why they have.
Just didn't mention that this is development. That's why
it
explains. Yes, it should be like this. No
it's
problem.
got this commit button that collapses everything, and you don't have the history anymore, but it gets back to speed.